Hati. Hey, space travelers! Ever wondered what it would be like to travel at the speed of light? Well, buckle up, because today we're going to break physics. Not literally, Einstein would be very disappointed, but we're going to dive deep into the wild science of near light speed travel, and trust me, it's going to get weird. First things first, why can't we actually travel at the speed of light? Short answer, physics is a buzzkill. Long answer, Einstein's theory of relativity tells us that as you approach the speed of light, your mass increases. So if you actually hit the speed of light, your mass becomes infinite, and that's bad news. Imagine trying to fit infinite mass into an economy airline seat. Not happening. But let's say we could somehow ignore physics, which we can't, but let's pretend. What would happen if you personally were zooming through the universe at 299,792,458 meters per second? First up, time dilation. This concept is one of the most fascinating and mind-bending aspects of Einstein's theory of relativity. Imagine a clock on a spaceship traveling close to the speed of light. To an observer on Earth, that clock would appear to tick much more slowly than a clock on Earth. This isn't just a theoretical idea, it's been confirmed by experiments with particles moving at high speeds. One of the most bizarre, brain-melting consequences of near-light speed travel. Time dilation can be incredibly confusing to wrap your head around. It challenges our everyday experiences and intuitions about how time works. But it's a real phenomenon with real consequences. The faster you move, the slower time passes for you compared to people staying behind. This means that if you were on a spaceship traveling at near light speeds, you would age much more slowly than your friends and family back on Earth. It's like having a time machine that only works in one direction. If you spent, say, a year traveling near the speed of light, decades could pass back on Earth. This isn't just science fiction, it's a consequence of the laws of physics. Astronauts on the International Space Station experience a tiny bit of this effect, because they're moving so fast relative to the Earth. That means you come back to find your friends old, and your relationships changed. The people you knew might have moved on, started new lives, or even passed away. The world you return to could be vastly different from the one you left. Your phone's software way out of date, and you'd have to catch up on years of technological advancements. Imagine trying to use a phone that's been sitting in a drawer for decades. It would be like stepping into a time capsule. And worst of all, probably no more new seasons of your favorite show. All the cliffhangers and unresolved plotlines would be ancient history. You'd have to binge-watch years of content just to catch up. The cultural touchstones and shared experiences you missed would make you feel like a stranger in your own time. Now let's talk about length contraction. The faster you go, the shorter distances become in the direction you're traveling. If you're zooming towards Alpha Centauri, a journey that normally takes over 4 years at light speed, the distance might seem a lot shorter to you because space itself contracts. Basically, you're fast enough to cheat distances. Take that, road trips? Okay, but what would you see at light speed? Turns out things would get seriously trippy. Due to the Doppler effect, light from objects in front of you would blue shift, meaning they'd look more blue, maybe even ultraviolet, stuff behind you. Red shifted, fading into darkness. So instead of seeing stars as twinkly dots, they'd warp into streaks, and space itself might look like you're inside a cosmic disco. Not to mention you'd experience something called aberration, where everything in front of you would appear to bunch up in a tight field of view, kind of like you're staring down a cosmic tunnel. Basically, space would look like a heavily distorted GoPro video on steroids. Another major issue, energy. It's not just any energy we're talking about, but an astronomical amount that defies our current understanding and capabilities. Getting to light speed would require an obscene amount of energy. Imagine the energy output of our entire planet, and then multiply that by an unimaginable factor. We're talking about harnessing the power of stars, or even more, like all the energy produced by the entire planet, times infinity. Our current energy infrastructure, with all its power plants and renewable sources, wouldn't even come close to scratching the surface of what's needed. And since that's a bit out of budget, we'd have to settle for near light speed instead. Even achieving a fraction of light speed would be a monumental task, requiring breakthroughs in energy storage and generation. Even then, you'd start accumulating so much kinetic energy that the tiniest dust particle could hit your ship with the force of a nuclear explosion. The faster you go, the more dangerous space becomes, turning even microscopic debris into lethal projectiles. So, yeah, you better hope space is clean. Navigating through the cosmos at such high speeds would require not just advanced shielding, but also precise navigation to avoid any potential hazards. The dream of interstellar travel is fraught with challenges, and energy is just the beginning. So, if we can't go at light speed, is there anything in the universe that can? This question has puzzled scientists and dreamers alike for generations. The speed of light, approximately 299,792 kilometers per second, is the ultimate speed limit in our universe, according to Einstein's theory of relativity. But is it really the end of the road for our cosmic ambitions? Actually, yes. Light itself, obviously. Photons, the particles of light, travel at this incredible speed, allowing us to see the universe in all its glory. But light isn't the only thing that can achieve such mind-boggling velocities. But also, theoretically, space itself can expand faster than light, which is why distant galaxies appear to be moving away from us at insane speeds. This phenomenon is a result of the Big Bang and the ongoing expansion of the universe. It's not that galaxies are moving through space faster than light, but rather that space itself is stretching, carrying galaxies with it. Also, quantum entanglement kind of cheats because information seems to transfer instantly. But don't get too excited because we can't actually use it to send messages. Quantum entanglement is a fascinating phenomenon where particles become interconnected in such a way that the state of one instantly influences the state of another, no matter the distance between them. However, this spooky action at a distance doesn't allow for faster-than-light communication. Physics still doesn't want us breaking causality. The laws of physics, as we understand them, impose strict limits on how information and matter can travel. Breaking these rules could lead to paradoxes and inconsistencies in our understanding of the universe. So while the dream of faster-than-light travel remains tantalizing, it also remains firmly in the realm of science fiction for now. So, in conclusion, traveling at the speed of light? Super cool in theory, but physically impossible unless you're made of photons. Near light speed travel possible, but incredibly dangerous, inconvenient, and likely to leave you very, very confused when you return home. But hey, who knows, maybe one day we'll crack warp drives or find a way to cheat relativity. Until then, we're stuck with boring old slower-than-light travel. Okay, walking is a little too slow. Someone get me a spaceship. If you like this video, hit that like button so hard it breaks the time-space continuum. And subscribe for more mind-bending space adventures. Until next time, keep your atoms intact and don't try to outrun light.